Wait.
Okay.
Neither's a chord. I mean, neither's a secant because neither of them have arrows.
Look again. Consider, according to the question, it says consider segment or S and line or
I'm
S.
saying the line on the picture.
The picture doesn't, but it does. If you put arrows, it will continue, right?
The first one is the chord, right?
The first one, the segment is the chord. It ends at S and R. Now this is very important because if I said name a chord and you put the second thing or S with the arrows on it, you've named a secant. All right, so it's very important. It's not being nitpicky. It's being correct. And then line RS would be your secant.
How do you write?
How do you write what?
One's with arrows and one's without arrows.
The arrows on top.
The arrows, look, right here.
Oh,
Okay? That signifies that it's a line. The other one signifies that it's a segment. Okay? Same picture. Why is segment TK not a chord?
It doesn't touch the circle at 2 points.
What doesn't touch the circle?
Okay.
Point K is not on the circle.
Which is weird
Okay.
because it's in the circle.
Point K is not on the circle. It's not on the outer edge of the circle. So that's why it's not a chord. Name a tangent to circle O.
T. No.
Tangent is touches at 1 point. L. H.
LH. Now you could either call it line LH, segment LH, or ray LH.
Oh, that's
Okay.
Okay.
Because all three of those are tangents. But it's the entire segment. You need 2 points to name a tangent because it's a line, a segment, or a ray. Now what do we call line L?
Point of tangent.
The point of tangency. That's the point where the tangent line hits the circle, which makes a whole lot of sense why it would be called a point of tangency.
Point of tangent is like an orange.
Okay, now here we look at a sphere, and I want to explain the picture to you because you're going to see these pictures in your book and you're going to be like, huh? What? Okay. If you look, this right hand is just to show you with the shading that it's three-dimensional, okay? It's a ball. All right. On the left-hand side, you can barely see it, but there's some little dotted lines in the background to try to show you kind of the inside that the ball bows out. All right? Okay. Point Q is the center of the sphere. It's not on, think of a basketball, okay? Point Q is not something you can put your hands on. It's in the exact middle of the basketball. Points F, point A, point B, and point C are on the basketball. All right? Now, point A would actually be like behind there.
Okay.
Okay? It's kind of in the backside. All right, if you look at the red line coming in here to point B, right here, you can see it's outside the ball. Then when it gets to point B, what happens? It goes inside the ball. Then when it gets to point A on the backside, you lose it, and then you see it again when it comes on the outside. So if you think of like a shish kebab skewer and a basketball, and you actually stuck the skewer through the basketball, and it went in one side and came out the other side. This is what this is trying to visualize for you or show for you.
Wait, it's like point B would be like a line on the basketball?
No, point B would be this right here. Just a point. Okay? It's not a line, it's just a point. Point A would be on the other side of the basketball. We just can't see it.
Okay.
Okay.
I see what you're saying.
And so it's coming through the front, going through the center of the basketball, and coming out the back of the basketball.
It's like if point A and B would be like where it's stuck.
Right, that's where it's stuck through. Those are the holes. Exactly. Okay? So is that clear to everybody? Okay. Name a line that is tangent to sphere Q.
Yeah.
Line EF. Okay? Line EF is tangent to sphere Q. Name some other lines that would be tangent to sphere Q that aren't drawn.
Oh, if C had a line.
No, not really. A tangent line comes from a point outside to a point on the thing, okay? AE, if I can get that line to touch A, okay, yes, because A is on the back side of the ball.
AC.
All right, ACE, no, not, what did you say?
AC.
No, not AC.
BC.
Not BC either.
BE.
B is on the ball, C is on the ball. BE, possibly,
Maybe.
depending on where E is, and possibly CE. depending on where they are, if I can get a straight line to touch them both. But it has to, a tangent line has to have one point that's not on the sphere and one point that is on the sphere. Okay? All right. Name a secant
It's
Secant would
AB.
be
AB.
With a line doohickey.
with a line doohickey on top of it. Line AB would be a secant. Can you name another secant that would be of that sphere? It's not drawn.
Q.
Not Q. Well, yeah, because Q, it's going to have the line will eventually have to come
Well,
through.
CE line.
Okay. CF, CF, definitely. CB, line CB, definitely. Any 2 points on the sphere, you draw a line through it, that's a secant.
But
Okay.
it isn't on the sphere.
If it isn't on the sphere, you can't definitely, because it may, when you connect them, it may be tangent. It may not go through twice. Okay? So if I was asking you for secants, putting CE is not a definite, it's a maybe. I want definites. And the definition of a secant is it contains 2 points on the sphere.
So the only definite one would be line or thing AB.
Well, no, also point A and point C are both on the sphere, so a line going through A and C,
And why wouldn't B and C be?
it would be.
Oh, okay.
And C.
And C and F, and B and F, and A and F.
And C and Q. Oh,
Okay.
Q's inside. My bad.
But E would not be a good combination. Now Q would, because eventually if it's a line, it's going to keep going.
But Q's inside of
But it's going through the center of the ball, so it's going to have to come out the other side. Okay. Name a chord. What's the difference between the chord and the secant?
A secant is
Secant
a
has a
line,
line
a chord
doohickey.
is a segment.
So all the things we just named that would be secants could also be chords. We just don't put the little arrows. Okay?
So BC, AC, AB.
But no, but AB wouldn't be because if it stopped at A and B, it wouldn't touch the circle. It wouldn't
Yeah, it
touch-
does.
Oh, 'cause
A
B's
is
a
on.
point.
It's a point on the circle. B is a point on the
I hate three
sphere, and so is A. Name 4 radii, none are drawn,
QC.
QF, QA, QC.
QB.
and QB.
It doesn't feel like B could do it because B looks so close.
I know it's hard to tell, but you gotta wrap your brain around it. So from the center
I'll go back.
to a point on the outside.
Wait.
Okay.
There's-
Now when we're talking about spheres, they're hollow on the inside. They're not solid.
Unless there's Jello inside.
All right.
Orange juice.
Now let's put our brains to a quick little test. What is the diameter of a circle with a radius of 8?
16.
Double it. What about 5.2?
5.2 times 2.
10.4.
No.
8 square roots of
Bulky number.
8 square roots of 3. When you are multiplying a radical times 2,
You don't touch the radical.
you don't touch the radical. You're just multiplying the whole number.
J squared. I mean J times
2j, not j squared, 2j. All right, now what if the radius,
7.
what is the radius if the diameter is 14?
7.
7, 13,
6.5.
6.5,
2.3.
2.8.
3 in.
3 in.
Very good. All right, I want you to draw a circle on your paper. We're going to do an introduction into tomorrow's lesson, something that we're going to learn tomorrow, but let's look at it. From the circle, okay, I want you to draw a point outside the circle. Completely like away from the circle. From that point, draw 2 tangent lines to the circle. So the it's going to be 2 different points of tangency on the circle, but they're both coming from that same point outside the circle. It's going to look kind of like an ice cream cone with a big ball of ice cream on top.
Oh.
Can it just be a ray?
That's fine. But now it's got to be tangent.
They have to be the same point.
Yes. And
Oh,
once
I see
you
what
draw
you're
it, what do you think is true about those 2 segments?
They're
It's something
equidistant.
crazy.
Very good.
I'm so smart.
And watch. Okay, here's my circle with my 2, here's my point outside my circle, okay? And then I have my two tangent lines drawn to these